Okay, so welcome all, thanks for coming. My name is Richard Tuin and I'm going to tell you in this slot, this last regular conference slot about Golang, giving you an introduction, hope to get you excited about the programming language. So I'm going to do that with knowing that you all have a PHP background and that you know some stuff, so I'll assume some of the things in there. Questions, please write them down or remember them, and please ask them afterwards for timing purposes. So first of all, who am I? My name is Richard Tuin from the Netherlands, Zwolle to be specific. I worked for the past 5 years for a company called Enrise, and today actually is my first day on the job at Igenic. Very excited to start there. Yeah, thank you. I've been doing PHP for most of my professional career, which is, I don't know, too long. Still enjoying it, absolutely. I'm not here to burn PHP at all, but I think Golang is a really nice addition to the programming stack. Also one of the organizers, together with Thijs and some other people, of the PHP Wellings conference annually in January. Quite an exciting experience, I think. And I'm also the creator of a project called Camilla Proxy. So I talked about that earlier today during the conference. I did a demo about it. If you want to know more, go to camillaproxy.com. But I also explain what it actually does during the presentation, as I use it as a use case to illustrate when Go can be a powerful programming language. So first of all, a bit of this, about the structure. I'm going to tell you about what Golang is, what problems it solves, and I'm going to give you a use case. Of where it shines, so to say, and after that I'm going to give you some tips and tricks to get started when you get home after the conference. So about Golang, I'm gonna tell you a bit about the origins, so why, show you a bit of a Hello World example to get some visual thing going on, and then show you some of the language features and what I think make Golang powerful. So the origin, Golang is a language that started out in 2007 at Google. So imagine that you're working at Google in 2007 and that you're doing projects at a particular scale, particularly exciting, I think, from a technical perspective, and that you're running on hardware that's pretty advanced. So you can do multi-threading and all that sort of stuff. Or you have the technical capacity for that, but actually it was really expensive to program these kind of things, because in C and C++, for example, the threading and the concurrency is particularly pretty erroneous to write, pretty hard. And one of the upsides of C and C++, for example, is that they are very efficient in execution, not so much in compilation, because the dependency management is really troublesome. You have all these header files, and they're interpreted quite a lot. If I'm not mistaken, and that really adds up to the time of compilation. Some programs take I don't know, minutes, hours to compile, and that's what they were stuck with. On the other hand, those languages are statically typed, so the strict typeness is really secure. And that's really nice. On the downside, it's not a very productive programming environment compared to interpreted languages like PHP or Python, for example. The downside that they have is that it is very slow in compilation. So the execution is not very efficient. So it's a request response routine that is executed every time, and there's been some optimizations in the runtime for PHP, for example, like a lot over the past few years, but it doesn't compare to a compiled binary. So yeah, those are the problems. Those are the problems, and what does Golang actually solve? First off, it's designed to be a very simple language. So the vocabulary of the language needed to be simple and very limited, but still be very productive. So that's what I tried to achieve. On the other hand, the dependency management, dependency hell that the people experience with C and C++, for example, and that they saw being better in PHP, Python, and some other languages, is that they wanted to improve that. They wanted to make dependency management and declaration part of the language. So I'm going to show you an example of that later, but they solved that. The garbage collection routine is somewhat controversial in Go, but it is actually built in the language. You don't have to clean up your own mess, your own variables. Freeing up system resources is thought of during the compilation process of your program, and that's something that Golang solves in that respect. And the most exciting part, I think, is the ease of making programs concurrent. So there have been quite some talks on the conference already about event loops and threading, and that's really an how do you say that, like a hot topic, I guess. But it's also a complex topic, not just to wrap your head around, but also to program in a secure way. So that's something you have to be constantly aware about, that your program is running, that your program is doing several things at the same time. So so that's what they tried to do in the language as well. I'll show an example of how they solve that later. So let's switch to a hello world example. So this is the really basic hello world in Golang. So the main package definition there and the main function is basically the entry point for executable binaries. So what this does here is that it imports the format library, the FMT, and it has a function called printline, and we use that to print out hello DPC2017. So the import line there is actually an example of how dependencies are declared. So they're, well, it's very similar to how PHP does it with namespaces and the use statement in the language kind of way. Under the hood, of course, it's different, but I think it's very intuitive and very small. So this is what it looks like, and let's talk about the application lifecycles for common Go and PHP projects. So this is a very simplified way of how programs work, but first of all, when you start a program or when you compile a program, it loads the files that are necessary. Can do the detection of loading during the compilation process, but then it compiles the code and then it executes it. So for PHP, this is very straightforward. So you get a request and then it does all these steps just to get the response. Now, this is very simplified, but I want to illustrate that with Golang. This is a little different, since you compile executable binaries that you run during the so-called build stage. So this has a binary that you can execute and that will run for a longer time, like for an indefinite amount of time when you start it. And when you get a request in, if you program a web server, that the program is already running, so you don't lose all that bootstrapping as you do in PHP. And the request is directly executed, directly handled, and then it comes to a response. So there's a bit of a difference, and this is very much simplified. There's a lot of technical stuff under the hood for both Golang and both PHP, but this is the biggest difference that's most interesting to you, I think. So now let's go over some of the language features that I think Golang that are unique to Golang and what make it powerful. So I'm not going over the language stuff that is common across languages, like iterating over loops, and it's not that different in Golang, and over the scalar types, and over too complex types, or types that are not relevant. They're too complex to explain right here. So slices is one of the examples of that. So let's start with maps. A map is basically mapping a key to a value. That's it. But since Golang is a static type language, as soon as you define the map, you define the type of the key. So in my example later, string, and then the value is also a static type, so that's an integer. And you define it like this. So this is the syntax. So you have map and then the brackets, which indicate a key, and then you have an integer. And notice the make function there. That is an internal function of Golang that allocates and initializes this map into your memory and then manages it. So this is part of how Golang can be effective as well, because this is the place of assignment of this type is indicated at build time. So using maps is pretty familiar, probably. This looks, well, I think it's literally JavaScript, right? Well, similar syntax, that is. And also, yeah, accessing parts of your map and then printing the map. So in this case, if you print the entire map with a print line function, it will be automatically serialized to a string. That's what the format library does. That's how it works. And now we get to like the different stuff in Golang. So structures are structs, as the keyword is. They are predefined data structures, basically, with named fields. So in this case, the name of this data structure is message, and it has a category and a content field, both of type string. So what you can do is you can create a new message data structure. You can assign it some values like greeting and hello DPC to the specific field. And what you can then do, how you access these fields, the content field, for example, is that you do message dot, and that's the syntax to access these properties. So that's not too special, but it's an interesting way of, I think, of handling data within your application, because this is like the foundation for messaging within an application that's concurrent. You can make cows in Golang, and why I make a cow is because of an example. If a cow greets, it returns moo, because that's what cows do. But why I want to show you this is that you can extend data structures with certain behavior, and that in this case the definition is func, and then the parentheses you have c cow which refers to the preview declared type, obviously, and that has a greet method with a return type of string. So that's that. And then you could say, hey, if I initialize a new cow, I can call c.greet, and it says, hey, cow says moo. So that's the basics for adding behavior to data structures. So you can extend this with other types. This is really interesting, right? You can make ducks with the same method signature. Now this is where it gets interesting, because both the cow and the duck, they share the same behavior. So that's what we call interfaces. So they have an interface in common. And in this case, it's the greeter interface, which can be anything that greets. And both the cow and the duck implement this interface. That is done implicitly in Golang. So you don't explicitly have to declare, like in PHP, like if the implements keyword, you don't need to do that in Golang. That's the compiler figures this out, and I think that is that's another approach, and I think it's a nice approach because it's very you don't have to worry about that. So when we have a tree, for example, so the cow it greets and the duck greets, so they both implement the greeter interface, but the tree does not. So because the tree stands there, and this is implicit. So this is how this is very transparent. You don't have to worry about that. So that's what I want to illustrate with how interfaces are declared. That's implicitly. So this is a use case. So if another part of your application you have the say hello function, which accepts a greeter. So any object or any data structure, any type basically, that implements the greeter interface, you can use it like that. So if you have a cow, a duck in a tree, and you all feed them to the say hello function. With the cow, it says moo, and then with the duck, it says quack, but with the tree, it gives a compiler error. So in PHP, this will be different. It will give well, maybe also a compiler error. I'm not actually quite sure, but you only find out when you run the application, not in the build stage. And actually, the error messages that you get are pretty helpful as well. So it literally says, hey, it's not a greeter, it's missing the greet method. So I think that's quite elaborate. So Go routines are, I think, one of the most fascinating things of the Go programming language. Actually, that's what makes the language distinct over other languages that allow for concurrency at the moment. So I'm going to explain this with a little example. But Go routines, they allow for concurrent program execution. So every time you introduce a Go routine in your application, what your application does is that it basically threads off or branches off in a separate path of execution. So what this allows is that if you have multiple CPU cores, for example, you can branch your application over multiple CPU cores, which is different from how Node does that, for example, with the event loop. So I'm going to show you with an example. The wait short function, it sleeps for 500 milliseconds. And the wait long, it sleeps for a second. It's not too exciting, but it's illustrating. So imagine that you have these two calls, and we call the wait long function first, the wait short function second. Now normally, oh, that was fast. Normally the wait long function runs, and then only after it ran, you have the wait short function. So they wait for each other. And if you add this little keyword here, the Go keyword, that's it. It's that little word. You start the wait long function, but it branches off in a separate path of your application in a thread, and it potentially, if resources are available, it will go to a separate routine, and the wait short function can then run in parallel or potential parallel. This is not guaranteed, but it's allowing for concurrency if your system supports that, basically. So that is basically how concurrency works in Go. You don't have to register events or event listeners or event subscribers or whatever. This is the model, and that's it. So between Go routines, you can communicate. And the example that I have is from the gobyexample.com website, which I can really recommend if you want to get started, or if you want some practicalities, practical examples. You can create a channel, and channels are used to communicate between Go routines, and they're also statically typed. So in this case, we use the make function again, and we have we define a channel called with the type of string. So channels don't have a real name, but you can put them in a variable, and then that's how you access them. Okay. So let's say we introduce, in this case, an anonymous Go routine that sends something into the messages channel. So sending something to a channel is indicated with this little arrow there, which may or may not be one of the least readable parts of the language. And then when you want to fetch something from this channel, that's done like this. So also with the same arrow, and then in this case, the ping variable is going into the incoming variable. The ping string is going into the incoming variable. Now, on the Go routine side, this is blocking. And on the main Go routine, in this case, the incoming line, that's also blocking there. So both the sender and the listener and the receiver are blocking until something comes in by default. You can put some buffers in place, and you can have your way around that, actually also as part of the language, but not going to show that here. So yeah, you can then print the incoming variable, and then that will result in the ping string. Now, what is a use case for a Golang program? So I've built a application called Camilla Proxy, and as the name says, it's a proxy for HTTP traffic, and it consists of a proxy element and a web interface, and it's used to inspect real-time HTTP traffic on your between your server-to-server communication, basically. And it looks like this, and it's designed to be working on production environments as well. So it needs to be really fast, right? So how does it work? Let's say you have your application, which talks over HTTP with the GitHub API, and you want to put the proxy in between. So how do you do that? This is where Camilla Proxy lives, right in between. So we have the proxy element, we have a web interface, and every HTTP information that the proxy receives, it forwards it to the web interface. So any potential client of this web interface, any visitor, can look at the HTTP traffic. Now, if you would have a non-concurrent application, your clients will potentially, especially if they're with many, block the proxy. So that's why I use Go routines to isolate. So the proxy is a separate Go routine in this case. Also, the web interface is a separate Go routine, and also actually each connection to the client is a separate Go routine, not just as a precaution, basically. So if resources are available, that is assigned to a separate Go routine. So also, actually, in fact, the communication between the proxy and the web interface are isolated in that respect. So imagine doing this with PHP. I can't even imagine how to do that. It will be a hell of a job, and I'm not sure it will be stable, even though, yeah. So how to get started? Just some few tips and tricks. So setting up your Go environment, what it looks like on your machine, running your first program, using external packages, also an interesting part, and some basic tools that you can use. So setting up your Go programming environment is actually pretty simple. It actually 2 steps, or actually 3. You download the package, that's step 1. Then step 1.1 is extracting that package into the user local Go folder. So you have to configure your path, that's step 1.2, also not on the page, but you have to configure your path so that the Go executables Go executable is actually in your bash path. So environments defaults take care of the rest of the folders. Folder mapping, so workspace in this case. So we create the directory home Go. So that's going to be your workspace. That's where all your source is going to live normally. So you can configure this with environment variables to live in a different place, but for the sake of convention and defaults, I would say don't touch it. But you can. So running your first program. It's the Hello World example from earlier. And as you see, it is in my workspace, in the source folder, which is where all your source files live, the hello application, and it's called hello.go. So now when I run this, I go to this directory first, and then I run go run, and then the file name. So with go run, you run only one file name, and then that's executed. So if that file requires some other files that you have stuff defined in, it will not do that. You need to build. I'm going to show that. So this is how you build. It's really simple. You can have some parameters to change the name of the output, but name of the output binary. But this is the essence. So it creates a binary, and you run that binary, and then it says hello DPC 2017. Simple as that. Now, when you obviously don't want to program everything yourself, you can use community packages. And this is how you do that. So outside of the language, the import struct import keyword, you have the go get go get command. So you have github.com/syrups/logrus, which is a popular logging library in Go, and that will download that code, that source code, actually to your workspace. So that's where all your code lives by default. Modern approach is a composer-like with the vendor directory. It's isolating dependencies, and you can make dependency manifests with a tool I'll show later. But this is like how it's built in with Go. So this is how you use such an external package. So you use the import keyword, and then you use the full URL, which relates to this place in the source directory. And the logrus name is what you use because it's the last part of the package. So you use logrus.info, and that's how you use external packaging. Some tools to use. What's a common toolbox? Editors and IDEs, Composer for Golang, and testing Golang applications. Okay. The editors and IDEs are, well, especially editors, pick your favorite. They have plugins readily available. And my personal favorite is the Golang IDE, which is part of the JetBrains family. Is very similar to PHP Storm. And PHP Storm also has a Go plugin. And in fact, Golang, their IDE is a fork of the Go plugin for PHP Storm. Also, Visual Studio Code is like my second favorite. It's really nice. It also has some plugins also for other languages, but Go really works well. And there are probably more, but these are the ones that I find that I recommend. Now, this is a simple one. So what Composer is to PHP is what Glide is to Golang, to a certain extent. Now, lucky us in the PHP community, we have basically one standard dependency manager. Go does not. Actually, I'm not sure if any other language has that, but Go has Glide and like more than 10 others. But Glide is something that I can really recommend because Glide looks a lot like Composer in terms of how you use it. So the manifest, like the Composer JSON, looks a bit different. It's glide.yaml. You hate it or love it, but it's a manifest as well. And you also use Glide install and Glide require, I think, and it feels and works more or less the same way. So if you're doing, if you want to isolate your dependencies with Go, I would definitely go for Glide. It's, I think, one of the biggest at the moment as well. So on this slide, I just quickly want to show you how testing can be very similar to what you used if you're using PHP unit. So using the same hello program name again, and if any file that you underscore with that you prefix with underscore test.go is not compiled into the binary, but is interpreted as a testing file. So if you run go test, as you see here, it will run the tests and it will pass or fail. So in this example, I'm using the community package assert, which is making testing very similar to PHP unit, for example, or any X unit, I guess. And it's using the assert.not_equal. I just want to test if 1 is not equal to 2 for the sake of demo. And that's luckily going to pass. So this is very similar, I would say. This is just to give you an impression of how easy it can be. That's it for now. I hope I got you excited about Go. I hope you feel some of my excitement as well. I'm very enthusiastic about Go programming. I'm still doing PHP a lot, and I know its advantages, and I know Go's advantages, and yeah, I'm very excited. That's it. Okay, thank you.